Good morning children. Welcome to our chemistry online class. So in last class we discussed about what are molecules, atoms, ions and compounds. So how can we represent a molecule by its chemical formula? What is chemical formula? Chemical formula is the symbolic representation of a molecule or compound. So how can we write a chemical formula? Before going to that topic, we need to know some basic topics and some basic things to write the chemical formula. So in today's class, I am going to deal about a very important topic which helps us to write a chemical formula. So let's begin. We know that these atoms having in Dalton's postulates, Dalton stated that atoms are indivisible in nature. But actually atoms are divisible. That we discussed. So if we check the structure of atom, it consists in the center it consists a nucleus. This nucleus is consist of neutrons and protons. And if we check the structure of atom, electrons are revolving around the nucleus. Here the representation is there, it is electron. So the neutrons are, which in blue color, they are given here, protons are in red color. Actually they have no color and all those things, they are very small, but in order to understand, it's given here. So inside the atom there is a nucleus, it contains protons and neutrons, and electrons are revolving around the nucleus. And these electrons are revolving around the nucleus in the shells. This orbital, this round like structures are known as shells. So we cannot put all electrons in the same shell because there is because there will be repulsion, because electrons having negative charge. This protons having positive charge, electrons having negative charge. So if you put all electrons together, what will happen? There will be repulsion, so atom will not be stable. So for the stability and all those things, according to that, these electrons are arranging. The electrons are arranging in each shell. These round like structures are known as shells. So the first shell, which is near to nucleus, it is known as K shell. K shell. This is a K shell. First shell is K shell and its number, that is 1, because it's the first shell, so it is K shell. The second shell is M shell, L shell, like this, K, L, M, N, like this it will move. So first shell is K shell, second shell is L shell, third shell is M shell, fourth shell is N shell. And number of electrons which carry in each shell, it is given by a formula, that is 2n square. 2n square. This n means the number of the shell. For example, how many electrons can we accommodate in K shell? That is, we can write, we know the n is equal to 1 for K shell. So it will be 2 into 1 square. That is, 1 square is 1. So 2 into 1 is 2. So we can accommodate 2 electrons in the K shell. What about L shell? How can we write this? 2 into the number of L shell is 2. So 2 into 2 square. So what is 2 square? 4. 4 plus 2, that is 8. 8. Similarly, M shell, 2 into 3 square. 3 square is 9. 9 into 2, it is 18. But it is having the capacity to contain 18 electrons, but it will carry only 8 electrons in order to reduce the repulsion. So the electrons are arranging like this method. This arrangement of electrons are known as the distribution of electrons in each shell. It is known as electronic. This arrangement of electrons in each shell is known as, or distribution of the electrons is known as, electronic configuration. We can call it as electronic electronic configuration. Okay, we can call it as electronic configuration. So what will be the electronic configuration? It is the arrangement of electrons. For example, this all will study in next chapter, but for your knowledge to write the chemical formula, I am teaching all this. So we know about each element. Each elements having a property. We know the periodic table. In periodic table, elements are arranged in the increasing order of atomic number. So what is atomic number? If we like carbon, we can write carbon like this. What is this 6 and 12? Here the 6 representing the atomic number. Atomic number means it is the number of protons or number of electrons. We can call atomic number as atomic number. Atomic number is either number of proton or number of electrons. That is number of proton. Number of proton. Number of proton or number of electron. What is this? Is this 12 representing the mass number? Mass number is number of neutrons plus number of proton, that is the mass of nucleus. So in order to write the electronic configuration of an atom, we need to know the atomic number. So atomic number of carbon is 6. So let's see how we can distribute this. How can we distribute this 6 electrons? So we know the atomic number is either number of protons or electrons. So how can we distribute this 6 electron in each shell? That we are going to learn. So it's having 6 electron. So in the K shell, how many electrons we can accommodate? It is 2. K shell it is 2. L shell it is 8. M shell also 8. Like this it will go. So carbon having 6 electron. Carbon having 6 electron. So how can you write the electronic configuration? So in first shell it will contain 2 electrons. So 2 electrons already distributed to the K shell. Then how many electrons left? 6 minus 2, 4 electrons. So in L shell it can accommodate 8 electrons. So the remaining 4 electrons will give to the L shell. So K shell 2 electrons, L shell 4 electrons. This will be the electronic configuration of carbon, that is 2, 4. Then what about other element? We will check the atomic number of other element. For example, magnesium. We will take magnesium. Magnesium's electronic configuration is 12. So what will be the electronic configuration? Atomic number is 12. So 2, K shell 2. Then 12 minus 2, 10. So in L shell we can give 8. How many electrons we distributed now? 2 plus 8, 10. How many electrons are remaining? 12. 2 electrons are remaining. So 2, 8, 2. This will be the electronic configuration of magnesium. And we need a very important term for our chemical formula, that is valency. So what do you mean by valency? Valency means the number of the electrons in the outermost shell. If we check the molecules, which shell is coming last, which is the last shell, that is known as outermost shell. The number of electrons in the outermost shell, it is known as its valency. For example, if we check carbon, we can see here 4 electrons are in the valence shell. 4 electrons are in the valence shell. So the valency of carbon is 4. The valency of carbon is 4. For example, if we check magnesium, its last shell is, which will be the last shell? K shell, L shell and M shell. So the last shell is M shell. So it is the valence shell. It contains 2 electrons. So the valency of magnesium will be 2. Similarly, we can find out the valency of all elements by writing the electronic configuration. For that, you need to know about the atomic number. So you have to learn the atomic number. That all we'll study in next chapter. But before that, I am giving this idea towards you. So this is the valency. So I hope all of you understood what is atomic structure and valency. So this valency very important, or else we can say the valency, we can define valency in other way also. We can find out valency in many ways. It is the number of electrons in the outermost shell. Not only this, we know if an atom, we said about atoms and its stability, and in order to attain the stability it will undergo for the formation of molecules. If the valence shell, that is in the last shell, contain 8 electrons, then only an atom will be stable. This rule is known as octet rule. If there is 8 electrons in the valence shell, we can call this atom stable. It should contain 8 electrons. Then only we can say an atom is stable. So this is known as octet rule. This all will study. So in order to attain the stability, this atom can, if for example if carbon atom, it can either share 4 electrons, or it can donate, or it can transfer electrons. Like so many methods are there. So if we check, we can minus, if we minus the valency from, that is number of valence electron from the 8, we can calculate the valency. So in this chapter we will give valency for you, so then you can calculate the chemical formula. But from next chapter we have to write the chemical formula in the basis of, we have to find out the electronic configuration, then only we can find out the valency, then only we can write the chemical formula. It is the correct procedure. Okay, thank you. I hope all of you understood this. So thank you. If you have any doubts, we can clear it. Thank you so much.